Dear students, in this question we are expected to obtain the Cartesian form of the locus of the complex number. The first question is given as modulus of z equal to modulus of z negative I. So we will first start off doing that question. So consider modulus of z being equal to modulus of z negative I. Now we know that the complex number is of the form x positive iy, right? Since z is equal to x positive iy, I'm going to rewrite this as modulus of x positive iy is equal to modulus of x positive iy negative I. Now this can be rewritten the right side as x positive. This is going to be I of y negative 1 inside the modulus. On the left side you retain it as x positive iy. Now since we got modulus, if I were to apply the modulus operation, this is going to be x squared positive y squared is equal to root of x squared positive y negative 1 raised to the power 2. Now squaring both sides, we would get this is going to be root of x squared positive y squared square. On the right side is going to be root of x squared positive y negative 1 square. We got to square them. Definitely the square root and the square, they get cancelled, giving you x squared positive y squared is equal to x squared positive y negative 1 raised to the power 2. Expanding the right side, I get x squared positive y squared negative 2 times y positive 1. On the left, it's going to be x squared positive y squared. Now clearly x squared, y squared, they get cancelled, giving me positive 2y. I'm going to move this negative 2y to the left. It's going to be positive 2y negative 1 is equal to 0. So this is the required Cartesian form that the question wants us to do. Now the question number 2 is 2 times z, okay, 2 times z negative 3 negative I is equal to 3. This is what we've been given. Now as usual, I would be taking z to be as x positive iy. So this would mean I've got within the modulus sign 2 times of x positive iy negative 3 negative I is equal to 3. I can rewrite this further as modulus of 2x positive I times 2i negative 3 negative I is equal to 3. Now clubbing all the real quantities, this is going to be 2x negative 3 and then positive I times 2i negative 1 is equal to, on the right side I've got 3. Now if I were to apply the modulus function, this is going to be root of 2x negative 3 raised to the power 2 positive 2i negative 1 raised to the power 2. So squaring both sides, we would have an equation of this form. On the right we have got 9. On the left, the square root and the square, they get cancelled, giving me 2x negative 3 raised to the power 2 positive 2i negative 1 raised to the power 2. We expand this, we get 4x squared negative 6 times 2 12x positive 9 positive 4y squared negative 4y positive 1 is equal to 9. Now this can be further rewritten as 4x squared positive 4y squared and then negative 12x and then negative 4y. I've got a 9 and a 1, that's going to be 10. I can bring this 9 to the left, so it's going to be negative 9. So I have got 4 times x squared positive 4 times y squared negative 12x negative 4y positive 1 is equal to 0. Now this is the locus in actually of the complex number z in Cartesian form. Okay, so that completes the result for this question.